All right, welcome back. We are COMP1115, Game Programming 1 in the fall 2025 semester at Georgian, and it's week 1, part 2 of our broadcast and recording together. And then the last part, we kind of did a course orientation and that kind of thing. And in this part, we're actually going to talk about what we're doing today. So we did getting to know your professor, and a course orientation tool setup is what I'm going to work on with you right now. And I'm going to talk about version control with GitHub. We're going to do a small tour of Visual Studio while we're installing it. I'll talk about installation options. And then we're going to get into variables and C# syntax, a little bit about pseudocode and flowcharts. And then it says tonight, but you know it's due Monday, right? Okay, so let's move on. So version control, what is it and why do you need it? Okay, so I want you to think of it like this. You're working in a team and you're coding, and suddenly your Doberman puppy, bites the cord on your computer and you lose everything. It's gone, right? And you've never pushed anywhere and you don't have a backup and your machine's off. You're in the middle of doing something, maybe something destructive, like where you were testing something, or even in the middle of a build. And now when you turn your machine on, your project is broken and nothing works, right? This is a very common thing, right? So what we do to avoid it is we use some kind of backup. And it's not Microsoft OneDrive or anything like that, okay? We don't use Google or Google Drive in projects when we work with teams. We don't do that from game dev. We use version control. There are practically many version control systems that are out there. The one that we're going to be using this semester is Git and GitHub. However, as a professional game developer, if you were going to use something like that, then you'd probably use something like Perforce. I'm just going to talk about this, but we're not going to actually do it. And let me explain why this is. So Perforce is an alternative to GitHub and Git. And you don't know what either one is, some of you. But the reason why people want to use Perforce is because they build a server that sits inside the game studio. Usually, let's say, for example, Ubisoft has their own Perforce server. And their files are housed in-house, right? GitHub is software as a service, owned by Microsoft. So is DevOps, right? And there's some fear that if I put my source code up on GitHub, even though it's private and whatever, it's owned by Microsoft, who knows if it somehow can be leaked out there and someone can steal my source code and remake my game or whatever. So to have perfect control, they use this, right? That's what they use. They use Perforce. We can't use this because we need to set up a server. And as you can see today, we couldn't even set up Visual Studio properly with IT, right? So setting up a server and me managing that server, that's not my job. Honestly, it's a whole other thing to manage the server and everything else. We can't do it, and that's why we don't use Perforce. Instead, we use Git and GitHub this semester. Next semester, we'll be moving to DevOps, next year, we'll be moving to DevOps. That's in 2026. Why? Because large files for Unreal Engine, yes. Git is the engine, right? If you want to think of it that way. Your local Git repository is where you can put, let's say, your application. And then GitHub is software as a service where you can clone your application, okay? You'll get it in a second, okay? But basically what it is Git, when you use Git locally, you create a container, and that container is where your software sits, all your application. There's also a similar container up online on GitHub, right? But that container is not the one that's local. So you're going to push to GitHub. That's what's going to happen through a remote. We're going to talk about that in a second. And then what you're doing is you're cloning or copying whatever you have locally to the cloud. That's what you're doing, essentially. That's what you're doing. It's not like Google Drive, where you have complete control of all your files. We don't do that for a lot of reasons. And one of them is versioning, right? Like, for example, how do I know that this file is the latest version? How do I know? Do I version it? Do I put like something like version 1.2, version 1.3, version 1.4? That's really tedious. What about if you have 1,000 versions or whatever? What about if there's a lot of changes to that file, like 1,000 changes? It's hard to keep track of that stuff, and it's inefficient. So we don't do it that way. So version control is really, really important because every time you make a change, you fix a bug, you add a feature. As an example, we make a push or a new commit to GitHub. That's what we pretty much do every single time. So what is Git then? Git, like I said, is a version control system, and it records changes to your files. What it allows us to do is take a snapshot of your files locally, right? And that's why we use it. Git is not GitHub. Git is a program that runs on your machine, on your computer. Okay. What about GitHub? And this is a great segue. If you haven't signed up for GitHub yet, now's the time. Go sign up for GitHub right now. You need a GitHub account for this course. You need a GitHub account for other courses that we're going to do together. Sign up for it now. Okay. Again, you can use your personal account if you want. You can use Georgian. A lot of times we use GitHub for a portfolio piece when we meet with employers. They kind of look. They want to look at your stuff. Show me your project on GitHub. As an example. Okay. So a great thing to do here is you can share your code with others. It's not just for backup. You can also collaborate with other people, like, for example, your teams, right? This semester, when you're building your 2D game with the people in your project team, you're going to be using GitHub. It's required, okay? So please sign up for now. It is required for in-class exercise 1 and for every in-class exercise from here on in. You must use GitHub, okay? Now, there are other providers of Git containers, if you will, right? One of them is GitLab. Another one is Bitbucket, and so on. There's tons of them out there. It's not just GitHub. GitHub is the most popular one, and it's owned and managed by Microsoft. So is Azure DevOps, which is another popular one that people use. We're going to use that one next year for Unreal Engine. So this will work great for you, GitHub, for our class today, as well as the stuff that you're doing with Unity. Okay. Is everyone signed up? Now, because people are signing up all at the same time, we had this issue this morning. It'll say like too much access from the same place. Because we only have one IP address for the college, and you're hammering GitHub with requests, right? So they might see it as a denial of service attack or something. So just take it easy. If it gives you an error, just wait and just try again, okay? While you're signing up.
For GitHub, for the username, should I use like my real name? Or?
I recommend it. But only because when you're done with us, when you're graduated from Georgian and you move on, you can take it with you. It doesn't have to be a Georgian account. You can use your real name, your personal accounts. And the reason why I recommend your real name is because it's more professional than my funny name, whatever it's going to be. They look at it and they're like, okay, unless it's a branded name, like somehow you're a Twitch streamer or something like that, and you have a funny name that you want to use on GitHub, that's fine, right? But for me, it doesn't really matter as long as it's the same GitHub account that I'm getting your stuff from and that it's private. All your repositories are private, and I'm a collaborator, I'm good. So what does this look like then, now that you're signing up? So you have your local repository, again, going back to your question, what is Git? What is GitHub, right? And I kind of work with my local repository on my machine. It sits on my machine, right? And all it really is a hidden .git folder that gets generated in your machine. And then what we do is we track all your files. Any changes to your files, that's what Git does, right? And it does it inside of a repository and inside of a branch of development, okay? So not only do you have repositories, but you also have something called branches, okay? And then what we have is this little connection from your local repository to your remote. This is called the remote connection, right? And it usually has a name. And the name that I want you guys to use is Origin. That's the name that we always use for your remote. Now, in practice, you can make any name you want. You can call it, backup. I want to push to my backup. I want to push to my development environment. I want to push to my build. I want to push to whatever. There's like a lot of things you can do here. You can have multiple remotes, and each one could be a separate repository where you're pushing your files to at different times, depending on what you want to accomplish. Okay? So some common terminology for Git is repository or repo. We use repo a lot, which is the project folder tracked by Git. Commit is, like I said, a snapshot. Branch, I like to think about the main branch as your single source of truth. This is your files. This is your, your project. This is where your build lives, if you will, inside of your main branch, right? You could have other branches. For example, you can have a feature branch. I want to add player movement. I want to add enemy AI. I want to add something else. I want to have a bug fix branch where I fix bugs. And then what you do is you merge. So merging, you take your other branch and you push it back up to the main, and it becomes, again, the single source of truth. In the merge process, you manage your merge, and there's sometimes, often actually, merge conflicts that happen between the files you've changed and the files that are inside of your main branch. You manage which changes you want, and then now you have a new commit with all the files merged together. Remote we talked about, it's just a connection to an online version of Git. Clone is when we copy your stuff from your remote into your computer. And then you have push and pull. Push when you upload to GitHub, and pull when you download from GitHub. There is no direct access, like I said before. So you cannot go like up on GitHub and go into a folder and then change the name and do all this stuff and upload a file. You can't do that kind of stuff. And for obvious reasons, because now if you do that, you're creating a new version, right? So that's your common terminology. And we're going to go over this over and over again. One of our workflows today is going to be this: git add, git commit, git push. Git add, git commit, git push. When do we do that? I changed something. I added something. Git add, git commit. In the message, in the git message, you're going to say, I added this, I changed this, I fixed this, whatever it is, right? And then push, it goes up to GitHub. And then now our GitHub is updated with our latest changes. Okay, so git add, git commit, git push. So again, what we talked about is Git is a local version code and control system on your computer, right? GitHub is a cloud platform, software as a service, and then we can think of Git as the engine and GitHub as an online garage. I want to include this section for you because your machine, the machine in front of you, probably doesn't even have, unfortunately, Git and GitHub installed, right? So the way to test this for your personal machine is if you open up a command prompt. Let's open up a command prompt together. If I do CMD, so I go to my start menu, and if I type in CMD, enter, then I get a command prompt that looks like this. Okay, I'll do that again. So again, you're in your, I'm just going to make this a little smaller. By the way, if your command prompt is too small and it's hard for you to see, you can always right-click on your title bar, and you can go to Properties, and you can change the font on your command prompt to whatever size you want. I've just made mine really big so you can see it. How did I get there again? I went to my Start button, and I just typed in CMD, CMD, all right, and then pressed Enter, and that's your command. So command prompt, this has been around longer than I've been around, almost. Okay, not true. But MS-DOS, made by our friend, right, Bill Gates, way back in the day when he first made Microsoft, you know, he made this, and he made MS-DOS, right, the disk operating system, and that's what this is. You can see here when I ran it here on our local machine, it's pointing to the G drive, and for you it might be doing the same thing. But if we want to point it to a C drive, we can just issue a C colon command, just C colon by itself, and press Enter, and it'll switch drives to your C drive. This, if you're a Mac user, is like switching volumes. I'm switching from my G drive or my D drive or my E drive to my C drive. My C drive is my main drive where I do all my installations. Okay? I don't have to do it here, but I'm just going to show you how this works. Okay? The other command that you can issue in DOS is dir, which is directory. It's going to show you a directory of all the files and folders inside of your C drive, okay, as an example. So dir is your directory command, okay? Again, don't worry about remembering this because I'm recording it, and we'll do it throughout the semester, so you'll get it as we go. If I want to change directory, it's cd for change directory, all right? And we can choose a directory. Like, for example, if I want to choose Windows, I can change my directory to the Windows directory, okay, if I really want to do that. Again, I don't need to do this all the time, especially not now, but I could. I'm just showing you some basic commands. And if there's a lot of stuff on your screen and you want to clear it, you can just issue a CLS command. That's clear screen, and it'll clear your screen. CLS, okay? Also, if you want to do the last command, you can use your up arrow on your machine to do the last command. It keeps track of all the commands that you've just put into your command prompt by just up arrow and down arrow. Okay, so it'll do those things again if you forgot how to do it. Okay, so some simple commands. Now what we want to do to test to see if you've got a Git installation, and by the way, it's probably not going to be working on my machine here because my podium isn't going to work, is if I type in Git and press enter, it's probably going to say is not recognized as an internal or external command. This is bad, right? And this is bad because we want to be able to do Git command line, and I can't do it today. But I want to show you what this really looks like, and at the same time, I'm showing you a Chrome Remote Desktop. Let's remote into my machine. By the way, Chrome Remote Desktop is what I'm using. If you actually look at Chrome Remote Desktop, oops, that's taking me there. But if you actually look at Chrome Remote Desktop, you can actually download and install Chrome Remote Desktop on your machine at home. You set it up so that you can access your computer, and then what you can do is you can remote into it even from school, which is what I'm showing you how to do right now. Okay? So let's suppose I want to remote into my machine at home. Right? I have two machines. I have a Mac Studio that I use for app development. That's mobile app development. Again, if you're a mobile app developer, you can't do it without a Mac. You need a Mac. There's no way around it. Even if you're using simulation tools, hybrid tools, when you want to do a build, you have to have a Mac, right? So I have a Mac for that purpose. And then, of course, I have my desktop, Godlike desktop, because it's an MSI Godlike motherboard that I have. That's what it was called. I just kept it. So on that, what I'm running at home, and what I highly recommend for you, minimum specs, if you're going to buy your own machine, are not the computer so much. I mean, the latest version of AMD, or at least an i5 on the Microsoft side, Intel, I mean, but an AMD computer that's fairly good in terms of CPU. But the more important thing is your GPU, and it should be at least minimum an RTX 3070, right? 3000 series, minimum. 4000 series preferred, right, at this point. So what I'm running at home is an i9 10900K, so again, a few years old in terms of CPU. And I'm running an RTX 4070 Ti. That's what I have, with 64 gigabytes of RAM. I have 1 terabyte, that's just for my operating system, and 4 terabytes for Unreal Engine. Unreal Engine, it's a pig, okay? So that's what I'm running here. So I have 3 screens, and what Chrome Remote Desktop does is allow you to look at all your screens at once if you want to. Again, this is if you want to do this. You can see all your 3 screens, right? So I have Discord over here and Outlook over here, and this is the screen where I do a lot of my work. But I can't work like this because it's too small, so you can kind of just go to the screen that you want to look at. So this is the one. And then what you can do is you can go full screen, and the performance is pretty good, right? So here's what it would look like, how it should look like for your command prompt. Okay, so here's command prompt as it comes up. And if I put in Git, I should get something that looks like this, okay? Not unrecognized command. So how do I do this, right? How do I do this thing? Because I also want to be able to do git -- version, and it should give me kind of a close version to the latest version of our code. Well, the way you can do this is you can manually install it, and I've given you instructions on how to do that here. Okay, so to install Git locally, I want you to go to git-scm.com. Now, this will not work on the computer in front of you. You have no admin rights, right? But you have to do this at home for your computer. So download and install git-scm.com. And please, I'm not going to go over it right now, but please follow these steps. Okay? It gives you a step-by-step instruction, screen by screen, on what to install. Okay? You need this for this course. Okay? Especially on the remote week, which is week 4, where you're going to be doing Git and all that stuff. Make sure it's installed, please, on your machine that you have here or your machine at home. Okay? And I'll make sure that it's installed on your machines here next week by escalating the crap out of it with IT. Okay? So that's what I'm going to be doing. Okay, so that is Git and how to get it. At the end, you should see something that looks like this, Git -- version and your version. And you should be able to do a couple things. There's one final setup that you should do with Git, which is this. Git config -- global user.name and user.email. What you want to do here is identify yourself to Git and GitHub. So this email should be the exact email that you're using on GitHub. This name is a friendly name. When you make your commits, that's what's going to be shown on your commits. Who did it? And that's why I recommend using your full name, okay, when you're making your GitHub. Like when you're combining with somebody else in your team, how do they know who did it? I mean, they might get to know your alias or whatever, right? But it's just easier to say, oh, that was Tom. He made that commit, as an example. All right, so that is your first time Git setup. Now, what we want to do here with our machines, and I'm talking about like the machine in front of you, there is something that we can do. There is a GitHub desktop app that you can download. And the way to get that is through Apps Anywhere. So if you actually look at Apps Anywhere, okay, here's Apps Anywhere. And then you can look at, if you actually type in GitHub, right, you can see that there is a GitHub desktop app right here. You can launch this, and what it will do is it'll download and install the GitHub desktop app, and there'll be some questions, and one of them will be, can you connect your GitHub desktop to your account? Yes. The command prompt is you just click on the start button and type in CMD. Yeah. Okay, so that's how you get Apps Anywhere. Apps Anywhere, like I said before, there's a lot of apps here that are built in for a machine in front of you. You can also use some of these on your computer. However, highly recommend you don't, because then you'll be working with IT on your machine, right? So don't do it unless you absolutely have to. Like if there's a piece of software that's here that is paid for, that you want access to, and that you're getting for free, fine. But otherwise, don't do it, okay? This is just for here, for this machine right here, the machine in front of you, like the school machine. All right, so, okay, so now that you've installed GitHub Desktop, right, one thing that we can do with GitHub Desktop is we can configure it, right? So, like there's a lot of stuff in here for options and stuff. And one thing is you can sign into your GitHub account. That's one thing you can do, right? And as well as you can identify yourself in here as well. Okay, so it'll ask you to identify yourself anyway. It'll say like what's your name and stuff, which is essentially doing this. Essentially just doing these two things. So questions I always get are, why don't we just use GitHub Desktop? It's a user interface. Guys, stop being addicted to user interfaces. Okay, we can do things much faster and much more accurately with command prompt. And I want you to learn that. It's a really great skill to learn because later on, you're going to do it anyway. You're going to do it in Connor's class when you learn graphics, okay? One day, maybe next semester. You'll be doing, GitHub command line all over the place. It's just better and more control. And besides, if you ever do use an app, you know the back-end workings and how it works. What's it actually doing? It's doing these commands. All right, on to a tour of Visual Studio. I want to do this next. So what I want you to do is I want you to launch Visual Studio. It should be available for you now. I'm saying this with my fingers crossed, on the machine in front of you. The way to do that is to go to the Start button and type in Visual Studio. And you're going to see Visual Studio 2022. Okay, not the installer. That's for you to do at home. The Visual Studio 2022 itself. When you do, it should bring up this. Now, it may not bring up this exactly. It's going to come up with a screen that says log in with Microsoft, okay, or GitHub. I think those are the two options, right? I recommend logging in with Microsoft at your Georgian College account, okay, because then Georgian College gives you some extra stuff. If you're going to use your own GitHub account, you can log in with your own GitHub account too. One of those things is perfectly fine, okay? And then it's going to ask you to choose your color scheme. Do you want dark mode or light mode? I'm a dark mode person, so that's why I'm in dark mode, okay? But you may not like it. You may like light mode for some reason, okay? Go ahead. It's okay. I don't have any prejudice against those people with light mode, okay? Even though I can't look at your screen, but go ahead. It's on you, man. It's a personal choice. It's like looking in your closet. I don't want to do that. Do it. Whatever you want to do. After you log in, I want you to come to this screen, please. And when you're there, let me know. Let me know when you're, I'll wait a few minutes, and when you are, I'm going to get you guys to raise your hand and tell me that you're good.
There's an option here saying allow my organization to manage my device. Like keep this.
Is that on this?
Yeah, on the.
Yeah. Yeah, sure. Yes.
Sorry, I brought my own laptop, but I'm doing the GitHub setup right now. I just wanted to know for the configuration.
Mm-hmm.
There's two dashes
Meanwhile, the rest of you log into Visual Studio, please.
Right here. So it's with that file.
Yes, so it, big dash dash global, that is an actual thing.
Okay.
I typed it in. Yeah, it's only going to manage the device in front of you. You don't want the organization to manage your device. If ever you get that request from Georgian, like let's say you're adding Georgian College to your Outlook, say this app only. Never allow them to to manage your device, or else somehow certain things, policies come into your device that you don't want, okay? And you don't want them to lock you down. Please don't allow that. That'd be very unfortunate and really a pain in the ass. So just literally just say this app only. If when you're actually using your device, your personal device, okay? Okay, is anyone not here? This place right here.
We're gonna run the VS Studio installer again.
What?
or-
You do?
Yeah. Yeah, when I run just here.
Yeah.
It's,
I'm so sorry, man. Do you have remote access to your machine at home? Okay, so you're gonna have to follow along and
yeah,
use,
that's
see
okay.
my
I've
video
used
later.
VS Studio
I'm sorry,
before,
I'm
so
sorry.
it's okay. I'm not gonna be totally lost.
No problem. Anyone else have any issues? Yes, you have an issue? What's the problem? Personalize your video. Yeah, so you want to do dark mode or light mode? Yeah. Sorry, yeah, there is a development setting option. Don't do that. Just leave it alone. Pick general. Okay, so if anyone else have any issues, let's move on. Okay, so now what I want you guys to do is go to here where it says create a new project. Create a new project. Click onto that once. And what it's going to take you to is this. Now, this is what I'm worried about. Okay? Did it actually install anything for you? Okay? Give it a second. It's spinning, like for me too. And it's coming to this screen. Okay? Now, notice that there are a lot of languages that are here. All we care about is C#. So you can filter up here where it says languages to C#. What we want is the console app, this one right here, console app. Click on this once. Okay, so console app, that looks like this. By the way, if you actually filter for console app, just to be clear, and if you type in console, there are more than one console app, okay? I don't want this one. Do not click .NET Framework, just click this one. And you know that it has C#, Linux, Mac OS, Windows, and console. That's what you want, okay, this one here. Then click Next. By the way, all this is in the PowerPoint slide deck, if you missed it. Okay, now that we're here, this is the next step. And when you're here, your project name that you're going to use today is In-Class Exercise, or ICE1, all in caps. ICE1. Your location is problematic, okay? Please do not use this location, as it's most probably managed by OneDrive. Any location managed by OneDrive that we use for development is messed up. Okay, it'll mess you up, OneDrive, right? OneDrive sucks. Sorry to say that, Microsoft. You're a good tools company, but OneDrive is terrible. And under the location, I want you to click these ellipses, please. And I recommend putting it somewhere like Downloads. Okay, make a new folder in Downloads. Let's call this Georgian. And then inside of Georgian, so double click in there, and make a new folder, let's say for our class, so COMP1115, and then double click inside that class, and that's the folder that I want you to be in. So basically you're going to put inside the COMP1115 folder, inside the Georgian folder, inside of your downloads, okay? And then click select folder. So your path should look something like this: C:\users, your name, downloads, Georgian, COMP1115. And then ICE1, okay? Now there's a checkbox here to say place solution and project in the same directory. Please don't do that, okay? And are you with me? Anyone not with me? Yes? What's the problem?
I just arrived.
All right.
Finished registering.
I'm so sorry, right? Don't worry, you can have a video you can watch later. Yes, what's your issue? One second. so now that you have the configuration, we have ICE1 in here. I know it's hard to see because it's really small. And everything is ready to go. Please press next. There is another check mark you have to put here. So there's an option for do not use top-level statements. Please check that. That is a check mark. Please do not use top-level statements. Let me explain why we have to do this. So back in the day, they used to have all the configuration we love in C#. And now that they've gone multi-platform, where you can do C# on Linux, Mac OS, Windows, and all that kind of stuff, what they've done is they've removed certain parts. And that's okay if you're an advanced developer. But if you're a student who's learning for the first time, you want the classic view. And what this is, if you check it, it'll give you the classic view of what we used to use back in the day. It's the right way to learn. So you want to check this. And then click Create. Now, if everything goes well and Visual Studio is installed properly on your machine, sorry about that, then you get something that looks like this. You can always zoom in by using Control and your scroll wheel to make it bigger if it's too small for you. Okay? It's too small for me usually, so I kind of scroll in. Okay? One thing I also like is I don't like the slim scroll bar, right? So you can see the slim scroll bar on the right here. If you just right-click on your scroll bar anywhere and you go to Scroll Bar Options, then what you can choose is I want to, instead of using the way it is, I want to use Map Mode. That's what it says. Use Map Mode for vertical scroll bar, and then choose Medium. That's okay, and press OK. And now what you're going to see is a scroll bar that looks like this. Okay, I'll do that one more time. So right-click on the scroll bar, go to Scroll Bar Options, click on Use Map Mode for vertical scroll bar. It's a radio button right here. Okay, and then once you click onto that, leave it at medium and press OK, and you're going to get a map mode as opposed to a regular scroll bar. Why this is really great is you can kind of do a preview of where you're looking when you're scrolling as opposed to scrolling randomly. Okay, so it's really good. Other things to note as a tour of Visual Studio at the top, notice that there's some filters here, right? And you can pull down different filters to look at different places. Right now, there's only ICE1 and Program and Main, but later on we'll have more than one of these things where you can jump to certain parts of your code right from the top. Let me explain what we got here right now. C#, it uses curly braces. And it uses curly braces like this. I'm going to make it even bigger so you guys can see it in the back. Here, how's that? It uses curly braces because C# is a C-influenced language. C-influenced language. The granddaddy of all modern languages is C, not C++, and not anything else. C, and everything pretty much comes from there. Okay? Why aren't we learning C, you're going to ask? Because C is not what you need for Unity. You need C# for Unity, so we've elected to go with C#. In terms of programming languages, there are high-level languages and there are low-level languages. Okay? When I first started programming, I learned assembly. Okay, that's a very low-level language. That's like right almost to the metal. One level below that is zeros and ones. Okay, that's what I used to learn when I grew up. Okay, and I programmed like a little Space Invaders game in summer camp with assembly language when I was 10. Okay, but that's me going back in the day when we only had 4K of memory in our computers. Yeah, 4K. But now what's happened is we go to higher level languages. Higher level languages mean away from the metal, away from the hardware, more and more farther away, right? The higher level of the language, the easier it is to use. There's more abstractions and everything is done for you, like more memory management, easier to do stuff. The higher level of the language, the less performant it is. The lower level of the language, closer to the machine level, the more performant it is, but way harder to code. If I'm coding in assembly language, it's going to take me like 10 years to do what I can do here in 10 minutes, right? Seriously, it's a long time, right? And there's not many constructs that you have ready to go in assembly language, right? In C, you have some stuff. That's a little bit higher than assembly language. It's I would say the next level. So it's like machine language, then you've got, assembly, and then you've got, C, And then above that is everything else, right? C++ would be just above that. C++ is an extension of the C language. It includes object-oriented programming. And above that, you have C# and Java. That's that level that they're in. Most likely, Kotlin is a little higher than that, and Swift, they're kind of higher in there. JavaScript is way up here, like way, way higher than that. And Python is probably even the highest level. Why? Because it's the simplest language, the least amount of syntax, and super easy for scientists to use. Python, which is why it's so popular. Easy to use. Lower level, more performant. Python, however, is interesting because it's performant and high level, which is kind of neat. Okay. Python is not used for game dev. We use C# or C++. So C# is a C-influenced language, which means we have the similar constructs to C. The construct that we have here is curly braces. Curly braces denote or separate an area, like all this thing here. This is a container that's inside of this namespace. I want you to consider a namespace as a separator. That's what we're doing. That's all we need here. I don't need it. I don't need the namespace, but it's good to have it because what it does is it separates your program into its own little container. Okay? That's what this namespace is. Below that, there's another container called the program. Okay? And this program is a class. So the class is a blueprint for objects that we're going to create. In Unity, which is what you're going to start learning now, you're going to kind of go right into using classes right away, right? Unity's classes you need them for any kind of behavior you're going to add into your game objects, okay? So here at this level, this is the second container, okay? And further down, there's the third container, which is your function, okay? In C++, they're called functions, but in C#, they're called methods, okay? Methods are behavioral pieces of code that do something, some kind of task. That's what they're going to do. Programs can have methods like this one and data. Those are the two things they can have. Programs can have methods and data. Data is where we store stuff in variables, and methods is where we do something with the program, okay, with the class. So in here, what we really care about is this, right, which is a statement, okay? Each line of code here is numbered from 1, in this case, to 11, and we sometimes kind of reference the line of code. So for example, line 7, we have this console.writeLine, and so on, right? Notice I said console.writeLine, right? And that's exactly what I'm doing. Console, like this green color, is the class. It's a container. And this container, this console container, contains all the methods for the console. So console.writeLine is one method that exists inside the console class, the console container. Don't be afraid. I know this is a lot, just saying these words, all right? But you're going to get it. We also have something called a dot accessor. The dot accessor allows us to access stuff inside the container. So for example, program has main inside of it. If I did program.main, then I can access main. Okay? Here, console is the class, writeLine is the method, console.writeLine dot is actually something that is the dot accessor, if you will, to access the writeLine method. Okay? And then we have this. All right? The method has a signature. Okay, let's go back. Here's a method too. This is a method, right? Methods have signatures. That's what they're called. Okay, don't be afraid of the word signature. Okay, it just means how it's formed, right? So for example, it has a name, main. That's the identifier for this method, main, right? You can make your methods, you can call them whatever you want. In this case, this is a special method, right? And we want to use the main method in our first program because we consider this this is a keyword for you guys, entry point into your application. So the main method is, we can say, triggered when this application launches, which means any of the statements, this is a statement, inside the curly braces in this main method are also executed. Okay, let's go back. Statements, I said, right? Statements have some kind of command. In this case, we're saying, hey console, and that's how we're going to use it, like this, hey console. I want to, call the WriteLine method, and this is my command, and here is my termination point. The semicolon terminates the command. You must have a semicolon on every statement. If you don't, you will get an error. See this little red angry mark? This is an error, and this is a syntax error. There's a bunch of different kinds of errors that you can get, and this is one of them. Okay? So we can put the semicolon back. You can try this yourself. You can see the red angry mark, and that's something we need to do. There's other things here as well. For example, we have this inside of the WriteLine method. But actually, when I say inside of, I'm saying it's being called by being inside of these parentheses. Methods need parentheses, right? The parentheses, opening and closing brackets, call the method. When the method is called, all the stuff inside the curly braces is executed. It runs, we can say, okay? So now we have this stuff here that goes inside the method, right, which is hello world. This stuff is called a string literal. It's a string of characters. That's why it's called a string, right? It's one character at a time, and it's inside of these quotation marks. And what it's done, when we do this, we create a string literal. There's other types of literals as well. A number, if I put a number in there, that's also a literal, right? It's data. So I want to pass a string literal to the WriteLine method by putting it inside the parentheses. That's what happens here. Okay? So what am I saying is, hey, take hello world, this string literal, pass it to WriteLine, and if I want to run this code, I'm going to build, right, compile, and run. That's what I'm actually doing in one click. I'm going to go to this plus button up here, or this play button up here, and click it. And when I do, it's going to pull up a console window, and it should say hello world with a bunch of other squiggly stuff. And just to show you this, so you can see it bigger, we can also change the font of this window to make it a lot bigger so you can see it. Hello world. Okay? Hello world is the first program that every developer has ever written, right? You are new, some of you, and welcome to the developer world, as you've just now ran your first hello world program. Hello world, there's only one way to do it. Hello, comma, space, world, exclamation mark. If you see it any other way, it's wrong. Seriously, right? So they've done it right here, but you might see it wrong some other places. Tell people. They'll be proud of you, right? Hello, comma, space, world, exclamation mark, where hello and world are capitalized, okay? It's very important. This is the first program you've ever written. This is fantastic. We've got our first program here for the first time, and we've run our console WriteLine. I want to connect this program to GitHub. I want to connect this program to GitHub. What happens if my little Doberman puppy comes into this class and, like, I don't know, takes my cords out and uses his teeth? I'm going to lose my program. I'm insane. I'm going to go crazy. I want to put this up on GitHub. So what we can do is at the bottom right here, I want you to start, I know it's hard to see, but way at the bottom right here in Visual Studio, right here, you can try, and I don't know if this is going to work, so forgive me if it doesn't. I can try adding it to source control. It says add to source control git. Okay, let's try this out. And then it brings up this little dialog box. Okay, let's try that again. So I clicked on this little add to source control git. It's going to bring up a dialog box when I click onto it, like this. This is called a dialog box. The reason why is it's asking you for dialogue. It's asking you for input. Okay, we talked about a couple things: the title bar, the toolbar, the dialog box, the default accept and cancel buttons. Those are default buttons. We're going to talk more about that this semester. A little bit of Windows for you. I want to choose local only, okay, local only. And what it's going to show me is the folder path that I am right now. C:users, my name, downloads, Georgian, da-da-da, okay? I do not want to add a README file. Please don't add that. but I do want this, a gitignore template. Visual Studio has a bunch of files happening in the background that you can't see, right? A bunch of configuration nonsense. We don't want to put that configuration nonsense on GitHub. Too many files. And as we move into Unity, Unity has a bunch more, like, I'm not joking around, 30,000 of them, all right? You don't want to push 30,000 useless files for one line of code, right? So we use something called a gitignore file. The gitignore file tells Git, our local system, what to ignore and not to put up on GitHub, right? So that's what I want to use this. And now let's click create, and I'm hoping it's going to work because I don't have local Git. Did it work? I don't even know. Probably. Here's how you can tell. Git changes. It did work, okay? So where do you get this Git changes? There's a little tab at the bottom of your Solution Explorer here that should include Git changes. If you can't see it, you can go to View, right? View has every little window that you might want is right here. So if you want to see your Git changes, you can go here to the View Git Changes window, and then you can see that little tab, right? Same thing with terminal. We want our terminal, our command prompt. I can go down to terminal and click onto it, terminal. And it'll bring up our command PowerShell, all right? And nicely, it's put us inside of this folder. Now, this is the test that I want to do. Let's try typing in Git and press Enter. Okay, and this is what I expected. Git is not a recognized as a term. So even though we were able to do this, this is built into Visual Studio. For today, I can't do commands here. I can't do it. In the future, we're going to do commands right here. For now, we're going to use this tool right here. Okay? It still will work. And that's what I was afraid of. All right, so we've done our first commit. That's what we've done so far. And I wonder if I can configure this. I can. So what I want to do now is let's make a new repository. So I'm going to go up on, I can close this off. I can go up on GitHub. Let's do that together. Here's my GitHub. Yep. Now, I own Georgian College. That's right. When GitHub first came out with organizations, I stole the Georgian College organization for myself. No joke. More than 10 years ago. All right? And later on, Georgian College came around when I was in teaching. I kind of moved around. I've taught at Centennial, George Brown, Durham, Canadore, all kinds of places, Ontario Tech University. And they contacted me and they said, can we have that, your GitHub Georgian College organization? And of course I said, no. Right? Because I knew somehow I'd be back. And so I have this Georgian College, right? And I'm going to create a new Git repository. What I need to do now is sign in. So sometimes what happens is they sign you out, and I'm glad they do. So you got to use your two-factor authentication to do this. You may have to do it as well. Okay, let's try that out. And once you've done everything, I'm going to use this one. I'm just going to kill this one for a second because I already started this earlier today and I want to do it with you guys. So let's just delete this repository. Yeah. 1 second. So I can start over with you guys. And I'll show you how to do that. So again, I want to create a new repository. There's two ways to do it. You can click the new repository button that you see in front of you. It's a green button. Or you can create this. There's a plus button typically at the top right corner of your thing. Sometimes it won't appear until later. So you can click the new button. When you do, you're going to have your name here like this. Okay? So whatever your name is and then your repository name. I'm going to have Georgian College and a bunch of other ones. By the way, I own all those other ones too. Not joking. I did it way in advance. George Brown too. So I know it's terrible. It's evil, right? But it is what it is. So here's my repository name, and I can choose whatever repository name I want. You can put whatever you want in there. But however, this is what I'm going to do. I'm going to encode it like this: COMP right? 1115 dash fall 2025 dash ice 1. Now, you don't have to do it this way, but it separates it quite nicely. By the way, my videos will be encoded like this too. COMP1115 fall 2025 week 1, part 1. So you can see what it is. So if you want the latest video, it's fall 2025. All right, so now that I've done this, there's other options here, like choose visibility. Do I want to make it private or public? Add a README file, blah, blah, blah. Leave it alone. Just do this and press create repository. Okay, this will make it so the repository is private by default. Okay, it should. If it's not private, make it private. Just so you can select private or public right here. Okay, so just make sure it's private and click create repository. When you do, it's going to give you some steering instructions. These steering instructions here kind of define all the stuff you need to do on command line. So if I was going to do this on command line, I would actually type some of this stuff in. We won't do it this week. We'll do it next week when we have these machines in front of you configured properly. But it's important that we have this stuff because we want to connect our remote with our Visual Studio application right now. Okay? And the way to do that is if we go back to Visual Studio. Here's I'm in Visual Studio. And I want to, next to this, I'm in the Git Changes. So there's Solution Explorer here in the tab. And if I go to Git Changes, and if I go here on the right, there's an ellipses right here on the right side. If I click onto it, I can manage remotes. Manage remotes. Let's make sure everyone's here with me. Manage remotes. Okay. And you can see that if I manage remotes, I can add a remote in here. Okay. I can add a remote. I click add. When I click add, it's going to say the name, the fetch, and the push. Right? The name of the remote is going to be origin, lowercase, like this. And then the fetch and the push will be the same. We want to get that information from GitHub. So we go back to GitHub, and I'm going to grab, you can grab it from here. Okay, this is a place to get it. You can also just grab it from here. If you want to copy this part right here, you can do that. It's the same as this. These are URIs, right? Uniform Resource. It's almost like a URL, but it's a little bit smaller. Copy this, right? So that's the URI that I'm copying. Switch back to Visual Studio and paste it in. So it's going to look like this. Are you with me?
Yeah.
Anyone not with me? How about that? Okay, I'm going to wait. I'm going to wait. You're in the wrong screen. You're so wrong. Okay, so wait. So right here, where it says Git Changes, you're going to go here, and you're going to go manage books. And then you're going to go add. Oh, you did it already. That's you. Yeah, look, that's you. You did. You're good. Okay. All right, so now that you've got everyone else okay? Oh, one more person, 2 more people? Actually, here's something I can do if we're together. Can someone help those people? Huh? Maybe some people next to them? Come on, guys. Volunteer to help your friends out there. Walk over, they're right there. They're not going to bite you, I swear to God, right? You can help. You know how. Steps. well, it's using a user interface. We're not going to do it this way next week. And then I want to press save. Press save. And you're going to see your origin remote stored here. It should say origin here, and it should be here. Now, if you want to modify it, if you made a mistake, you can always go edit. And you can edit it again, okay, if you want to modify it. Okay? It doesn't matter, but origin should be lowercase. Fix it. Sorry. Okay? And origin, the reason why we use origin is it's a classic name for what we're going to do with a remote. Origin is the way we're going to push to this. Okay, so now that we've got the remote configured, right, we can press OK. And once we've pressed OK, if I want to push this thing to my remote, then notice that there's these little buttons here. On the top right, there's a little arrow that's pointing up. See this little arrow that's pointing up? Click it. And if everything goes well, it's initiating the push, and you're good. If you have to sign in, sign in. It'll ask you to sign in to GitHub. And so for the first time only, one time only. And once you've signed in for the first time, you're good. You're excellent. And if I want to check it, I can go back to GitHub. And if I refresh, you can see now that I have all my stuff on GitHub, right, that I had from my repository. Are you with me? Yes?
It's giving me a source control thing.
Okay. Hit the login. What's that? What's it? Remote already. Okay, that's okay.
Oh, it already. Oh, okay.
Is that it though? Is that you?
Yeah.
Okay. Okay, now go to the arrow on the top there. Hold on. Okay, check your remote.
Thank you.
No problem.
This is authorizing, right?
Authorized, absolutely. Yes. Refresh, that's 127. Okay, let's see if we can go back to GitHub and see if it pushed properly. Get out of this. Refresh this page. You're good. You're good. Okay. Now come back to you. Yes. Over here. Stay on the push remote deposit or CO. Or maybe you didn't set that properly. Right?
It's not raining.
Most likely.
Get along for
All right. So most of you, looks like you got it. You should see this. My friends, this is the first part of your in-class exercise, 1, okay? This part right here, which is the we do part. Yes. Twice?
Yeah. I might have
It doesn't matter, refresh. Looks good to me. Close it. Refresh this. You're good. Anyone else? Go back. All right, so now that we've got this, hopefully you guys are good. Now that we've got this, remember, I'm recording this, guys. So worst case scenario, if you messed up, it's okay, right? Because today you get a easy peasy 6%. That's what it works out to be. But anyways, if you look here, you've got a couple things going on, right? One is the commits. So there's 2 commits that were made somehow. Add project files, and it has my little picture on it, and add git attributes and git ignore, right? These were both done by Visual Studio, okay? So we want to make our own commits here, And by the way, if you want your little picture to be here, you can add it into your GitHub. That's what you can do, right? But I highly recommend you use something called Gravatar. Gravatar is a central location for your profile pic that you can add for various applications, like Microsoft, like a lot of other ones. It's free to use. You can log in and put together a bio as an example. And you can use your picture, and it'll be consistent across multiple applications, like WordPress, if you use that one day, or X, or LinkedIn, or whatever. Okay? All right, so that's Gravatar. So that's what I've done, and that's why my image looks the same everywhere. Okay? That's what it is right there. And that's who did it. That's me. Look, it's my name. That's who did it. You can see it's me, right? And I'm the one that made this push to this repository. But you can't see it. If I was going to share this repository with you, and I'm going to share it right now. All right, let's go share the repository. Here it is. All right. Here's my repository. If I was to share this right now, it's private. So if I take this, I'm going to do this. I'm going to go up into contents and into my content area. We're doing well with time. And if I share this with you, let's edit it. So here's my weekly GitHub repo. Right? Here it is. Even if I do this, okay, here it is, and let's make it bigger for you. So there's a reason why I'm doing this. Please follow along. Go to Blackboard now and try this link. Go ahead. What does it give you? It's a 404, right? It's a 404 because it's private. And that's what I'm going to see when you give me a private repo that I'm not part of. This, if you see private 404, is bad. That means you're going to get 0% on your in-class exercise. You don't want me to see that screen that you're seeing right there. It's a nice screen. It looks nice. It looks like you get a land speeder there or whatever, and AutoCAD, okay, but it's not really great, or not for me to see. So what you want to see instead is you want to see it accessible. Now, I don't want you guys to do this. Please just watch, okay? I'm going to make it public now. Don't do this. This is just for me, okay? At the bottom, there's a danger zone where you can change your visibility, right? You want to keep yours private, but I want to make mine public. I can change to public. And when I do that, I have to say yes a bunch of times, right? Once I do that, refresh your screens, the ones that you just came to. And now can you see my repository? That's what I want to see when I look at your repository. But how do you do that in keeping things private for you, right? On the left for your repository, under settings, there's collaborators and teams. This collaborators and teams link. Please click it under collaborators and teams. It might have something else for you. Do you see teams? What do you see? Because remember, I have an organization. You don't. Huh? Collaborators. You have collaborators. What I want you to do is I want you to add people, right? Add people or add a collaborator. And what I want you to do is search for me. So just put in my last name. So TSI OPO. And you're going to see that if you type in TSI LI OPOU, if I go back up one, if I go TSI LI OP, you should only see me like this, right? Click on my name and include me as a collaborator. If you do, I'm going to get an email with an invite from you so I can look at your GitHub repo. And by the way, I am now being bombarded with a bunch of emails, so you guys are actually doing the right thing. Thank you. Okay? Thank you. Yes, I've got some from Saya. I've got some from Bodsworth Lee. I've got some from all kinds of people that are coming in, all right, where they're asking me to add me as a collaborator. This is a good thing, right? This means if you've added me as a collaborator, then I can see your repository, right? And if I can see your repository, you're going to get marks for today. If I can't see your repository, and if you don't do this every single week, because I'm going to make you make repositories every week for practice, you're going to get 0 for that one. Please remember to do this. It's a very important step. Add me as a collaborator. Now that you've done that, we're good. We're almost halfway through your in-class exercise. We're going just slow. That's what it is, okay? We're really going slow. Let's get back to the PowerPoint and see what I've asked you to do. So we did this already. We did a little bit of what Visual Studio is. It's an integrated development environment. And usually back in the day, it was split up between code editor and compiler, debugger, linker. So all that stuff. It was all separate applications. A lot of it you had to do by hand using command line. It was terrible, right? Now with an integrated developer environment, we're all good to go, okay? I got you guys to download and install Visual Studio 2022 for home, right? And like I said before, when you decide to download Community 2022, right, there are some workloads to install at home if you were going to do this at home. These are the workloads. But my friends, this is a lot of work. Too much work, in fact. Don't do this. What you want to do instead is do this. Go to Visual Studio Installer, right, and import my configuration file. That's what you want to do. And if you import my configuration file, which is the .vsconfig file up on Blackboard, you will save yourself headaches because then your configuration and my configuration are the exact same, which is what we want if you're doing it from home. And where this is really great also is next year when we do Unreal Engine, it's also going to be great because you don't have to do this again. Well, you may have to update it because Visual Studio Installer updates regularly and all that kind of stuff, but you will not need to change too much is the answer, okay? Most of you will be set up nicely now. Okay, so then once you do that, we talked about creating a project. It's all here, making C#. And if you followed along, if you missed this step, it's all here. For people who came in late, you can use the PowerPoint slide deck or the PDF to follow along and catch up. We did all this work, and we came to this point, and we put this up on GitHub. But there's a couple things here that we want to talk about. One is the editor window, and the other one is the Solution Explorer. So if I go back to Visual Studio for a second, again, names are important. This is the editor window. This is your scroll bar, which with a map, right? This is your Solution Explorer, and the Solution Explorer actually you can drill down into it, and you can see some of the containers here if you just expand some of these arrows. Okay. Notice that there's two things. There's the solution that's up here, and there's the project that's down here. The solution and the project are called the same thing, ICE1. Okay? Sometimes the solution is called one thing, and the project is called something else. For example, if you have a multi-project solution, right? In this case, we only have one project, one solution, and that's how we're going to run it for the semester. Nice and easy. We talked about classes, and we talked about methods. And yes?
What is the solution?
The solution is just a container for projects. That's all it is. It's a folder. Okay? And what I want to talk about is some of the stuff that's here. Okay? So, again, we want to run the compiler, and the compiler, what it does is it takes those low-level binary instructions and creates either an exe, an executable, or a DLL. Okay, dynamic link library. We care about, for today, an executable. The executable is something that you can run on your machine. In fact, we've already done this. We've already created an executable. Let's take a look at your project file. So if I look at your folders, so again, I'm looking at downloads, Georgian, COMP1115, ICE1. Notice that there is an ICE1 folder, and inside there you have a bin folder, right? In the bin folder, you have a debug folder. In the debug folder, you have net8. And inside there, you have an executable, right? And if you can't see them, again, what you can do is you can go to View, the View menu, you can go to Show, and then what you can do is you can show hidden items, and you can go to View, Show, and you can show file name extensions. And if you do that, you can see that there's an executable right here, okay? So this executable can actually be double-clicked. If you double-click the executable, then it'll just run really quickly and close the window. Yes, is that a hand?
Yeah, my net8 is empty.
It's probably because you haven't built yet. Built. If you run your app, then it should put something in there. All right, so that's what it is. So it'll run, but then it'll go away right away. Why? Because it's a command prompt, and then as soon as it's done, it'll finish. It'll close because we haven't told it to stay open. It'll stay open for us in Visual Studio because it's a special command prompt that we're running in Visual Studio. We're running in the editor. But here, it's not running in the editor. It's running locally on your machines. Actual little program you made, right? And what we're going to be doing throughout the semester, right, is we're going to build these little executables in class exercise 1, in class exercise 2, and one might be built in another one. We'll talk about how to do that. Okay. So that's what we're doing. We're making an executable. We press this button to execute. You can also do start debugging by going into the debug menu. So if you go to your Visual Studio, at the top there's a debug menu, and you can actually start debugging here by pressing F5, right? You can also start without debugging, which is Control F5. But if you do that, it won't do any checking at all of your code, right? This is great if you just want to run your program like this, really quick, right? But if I want to run with debugging, I can just press F5, and if you do, it'll run it like normal. It'll actually compile and run and reintegrate everything. Running without debugging just runs your executable that's already been built. Okay, that's what it's doing. All right, so that's what this does, debug, the debug window. There's other things that you can do too. The build window, or the build menu, there's other things we're going to do here as well. One day we might clean our solution. Right? We can actually clean and manually build and rebuild our solution. Sometimes we need to do this when things get messed up. Okay? But for now, we're good. So that is a way of running our code. Right? And when we run our code, we actually build an executable. That's what this does. Okay? Hello world. Now, what I want to talk about is this stuff that we did. This little, hello world. We used a string literal, like I said before. And that's all it is. Right? But I want to talk about identifiers. So identifiers are a fancy name for names. Okay? So if I want to talk about a variable, I can talk about the variable identifier or the variable name. And when we talk about variables, which we're going to get into in a second, we've already talked about the hierarchy. The hierarchy is just using the dot accessor or the access operator to go from one level to the other inside of your containers. We talked about the containers, container levels. Namespace, class, method, okay? That's what we did. And the dot accessor can help us with that. But we're just going to keep going here because we talked about classes and methods. This is a little bit advanced. And we're going to talk more about classes and methods in week 13 of this semester, as well as in game programming 2 that Wallace is going to run for you guys next year in winter of 2026, next semester, okay? So we're going to do some of that, but not a lot. So again, classes have two primary things that they do. They have data and they have tasks. And methods are just a way of executing those tasks. And that's what we talked about. Just going to make sure that I covered everything for you guys. And I want to skip down to, because we talked about namespaces, I want to skip down to the program and main. So again, main is the entry point. That's what we talked about before. And then statements have to end in semicolons. We talked about that. Okay, so you should know all that stuff. And now we're into white space. Okay, this is interesting. So you can actually, C# doesn't really care about white space. I can actually write like console write line like this. I mean, you don't want to do it, but you could. You can also make it go on 2 lines. So for example, if I wanted to take console write line and just do something like this, it's perfectly valid. It's ugly. I don't like it, but you could do it. You could also write your curly braces like this. I can also write it on the same line as a curly brace. Okay, you can also do this. And totally valid, right? But also ugly, right? So I don't like this either. So the way I write my curly braces is underneath each other. There is a style where the curly brace is here, okay? Like actually here, okay? And this part is down here. And this part is down here. That's also a style you might see out there, okay? I don't like this because if I want to change this, I can't do a drop-in replacement because of the curly brace, right? I can't change the signature of my method because I have this curly brace that's hanging out here, right? But if I have this curly brace down here, then I can just do a drop-in replacement for my method and my curly braces are good. That's why I like curly braces on the next line. It's a coding style.
Because the curly braces are the end of that.
The beginning and the end of this area, which represents the code that belongs to this method. The beginning and the end of this area where the code represents and belongs to part of this class. The beginning and end of the namespace, okay? Where I can have more than one class inside my namespace, okay? That's what they represent, the beginning and end of your code block. It's a code block that it represents, okay? All right, so now that we know this, going back to this, white space is important. I can do multiple statements. Let's try this together. I want you to write multiple statements now. We're going to modify this. So we said hello world. I want you to do hello or hi there. My name is. Replace this with my name, your name, and I'm excited to meet you. Let's try that. So let's get rid of hello world. And what you can do is you can replace this with whatever you want. Like, for example, you know, hi there. You can do that. Hi there, right? That's the first line. Let's try that one thing at a time and try this out. So you can actually change the string literal to whatever you want. If I press play, you can see that now when I run the code, I rebuild the app and it's going to say hi there, right? And I can duplicate this a number of times. I can say, okay, let's copy paste. So I can say like copy 1, 2, 3. If I do that 3 times, and if I press play, you're going to see that statement being done 3 times. Okay, nice and easy. Why is that? Because I'm calling the WriteLine method over and over again. In fact, I can even call a WriteLine method that is empty, like this. WriteLine method that's empty. If I press play, then you're going to see that there's a line space with nothing in it plus 2 hi there's, right? How come? Yes?
Because it runs the code, it runs it in order. Basically.
Sequentially is what you want to say. It runs the code in the order that I put it in. Now, warning, that's not always the case. Example would be JavaScript or some other languages, even here in C#. Sometimes the code runs, we're going to say this later on, asynchronously. Okay? Asynchronously means it could run in whatever order the compiler wants. But in our case, because we're running C#, which is a solid language, it's going to follow one after the other. In Unity, you're going to have something called a coroutine, which is also asynchronous, right? That's going to run whenever it feels like it. It may not run sequentially. You may encounter something like that. But most of the time, the code is going to follow sequentially the way you've written it, okay? But my question is, how come this line here can work, and how come this line can work like this when this has nothing inside of it? I said that we need some kind of parameters, and I'm not passing in a string literal. So why is this working? Yeah.
It has default value.
Yes, but if you hover over on it, there's actually another reason why it's like that. Take a look at what it says. It says 17 overloads. Don't worry about what overloads are. Think about them as copies of the same function with a different signature. Signatures mean types of parameters, things that I'm passing into it. I'm only passing in right now one parameter, a string literal, this part right here. But I can have the function with the same name that have different parameters. And to find this out, if you hover over, and if you actually hover your mouse over WriteLine and click onto it, try it, hover over WriteLine and click onto it, it'll actually take you to the definition of WriteLine, right? Here's the definition of WriteLine. You can actually look at the source code of WriteLine inside of your console class. So this is the console class, and you can see that we have a public static void method WriteLine that has nothing, right? It has nothing. And we also have another one that takes in a Boolean value. Boolean values, data types we're going to talk about next week, are only true and false. That's all they can hold, right? Character value can only hold one character. A character buffer is an array of characters, right? And then there's some of them that actually have more than one parameter. Here's a function that has 3 parameters. All of these things that I'm showing you, same name, different parameter, is a different signature. All right? That's what we're talking about with signatures. Multiple parameters. Decimal, a double. You can pass in a float, an integer. So if that's true, let's close this up. That means that I can do something like this. Pass in the value of 2 and press play, right? And I can say 2 there, right? So WriteLine is very versatile as a method, right? It can even do 2.5f, right? 2.5f, try that. And it'll do 2.5. So why can I do this? This is actually a floating point literal. And if I take the F away, this is a decimal literal. And if I take the 0.5 away, this is an integer literal. Notice I said these different things. Integer, so whole numbers. Decimal, that means some kind of, fractional number, right? And a float, a smaller fractional number. A double the size of a fractional number, right? Those are all data types. And we're going to talk about them next week. For this week, I don't want to do this. I want to, you can delete these, by the way. What about if I want to add in an escape sequence? I can do that too. Here's an escape sequence. Try this. \n. \n. Right? And if I press play, then I get a space between them. Right? How does this work? \n represents new line. That's what it's actually an escape sequence. That's what this is. The escape sequence starts with a backslash and a special character. That's what it does, right? And by the way, \n is also called a carriage return. And now I'm dating myself. Because a carriage return, my friends, used to be part of something like a typewriter. Oh yeah, typewriters existed once upon a time, right? Typewriters, I learned how to type way back in grade 9, right? Back when, we didn't have any cell phones and there wasn't any fax machines. None of that stuff, right? They didn't exist. And there was no internet yet. Yeah. Typing, right? And what we had on the typewriter was an electronic typewriter, or electric typewriter. We had a carriage. And the carriage itself had basically a ribbon. And what it would do is it would use these keys that would strike the paper with ink from the ribbon and print out on the paper. That's how typewriters work, right? And it'd have a carriage, a little arm on the end of the carriage itself, where when you type stuff in, it kind of moves the carriage to the right, to the right, to the right as you're typing, right, until it gets to the end. And there's no more, you can't type anymore because you're right at the end, right? And then you have a little arm and you press it and it goes, whoop. That's the carriage return, seriously. And you'll know this because some programmers, as old as me, might still call this a carriage return, right? Remember, everything we do here in programming came from the original C language, which happened a long time ago, right? So a lot of these structures that we have here come from typing it in a typewriter or some kind of teletype machine, keyboards with no monitors, and a bunch of weird stuff, okay? So this is an escape sequence. There's many other escape sequences you can put in, and you can inject it into your string literal. Okay, that's something we can do. So that's an escape sequence. So you don't want to do that. But what we want to do is, my name is, let's do that. Hi there, my name is Tom. I put my friend Rich's name in there because one day he might be teaching this course and I want to surprise him when he sees it, right? But that's why I put it in there. And then I'm excited to meet you. Let's try that out. And I want you to put your name in there. Hold on a second. Let's see if I can do this. I'm excited. I'm really excited to meet you, right? There we go. Ooh, if I can type. I cannot type today, even though I learned how to type in grade 9. And if I run this thing, I'm going to do one statement after the other, right? Like I said, here's one statement after the other. Sorry, who had a question?
Yeah, just about the quotation marks.
Yes.
If it's not there, would it
Well, let's see what happens. Let's take away a quotation mark. Now you get red squiggly lines, right?
Yeah.
Red squiggly lines are like, hey man, you made a mistake somewhere. And if you hover over, it says the name hi does not exist in the current context because it's thinking that you're trying to pass in a variable with an identifier name hi. And of course, that's not what we want, right?
When you use like 2.5f,
That's different. That's a number, a numeric literal,
yeah.
right? There's no characters. I can't mix numbers and characters. If I try that, like if I try doing something like hi by itself, that's not going to work. Or hi 2, that's not going to work. Or any kind of space, that's no good, right?
Too high.
No, not even too high. If I do 2 and high like this, no good, right? Because it's not, doesn't mean anything. Yes?
I think maybe the reason you might be confused is because you typed 2F, which I
Yeah.
think turned into
2F is different. 2F, capital F, denotes a floating point character. That's different.
Just that.
Just F, yeah. Yeah, and there's other ones too. There's other characters too. Yes, thank you for that. So again, let's Control Z and coming back up. Here's something else. Whenever I use a method like this, right? Methods require, at the very minimum, right, the 2 parentheses. That's what they require. They must have 2 parentheses. Without these 2 parentheses, I get an error immediately, okay? It doesn't know what to do here. If I hover over, it says, only assignment, call, increment, decrement, await, and new object expressions can be used as a statement. It doesn't know what I want to do here, right? In order for you to, here's the key word, call a method, we must use parentheses. It's part of the method signature. I must use parentheses at the minimum. I must use at least this, at least. And for some of them, for some methods, like for example, if we write a custom method, this is not enough. Okay? So that's something that you have to know. One more thing. Oops. Control Shift Y. Oh. There we go. One more thing. When it comes to this kind of stuff here, like we added, these string literals. We did it a few times, and all that kind of stuff. And remember, we have, these different write lines. Write line, write line, write line. Okay. Here's something else. Could we not do it in one write line? Challenge for you guys. I want you to use one write line, and I want you to use the plus operator between the 2 things with the \n escape sequence to do the same thing in 1 line of code, not 3. Go. Okay, so instead of 3 lines of code, can I not use 3 string literals, one after the other, separated by a plus, right? And if I want the new lines, add the new line character at the end of the escape of the string literal to do it together. Try that out. See if you can make it work. Think about 1 line. So I'm only using 1 console write line, not 2, just 1. Not 3. 1 console write line. Can you do it? Pretty simple. Did you make it work? Or are you doing it somewhere else?
Oh, no, sorry. I was doing it on GitHub
Oh,
itself.
okay.
Yeah.
You got it to work? Very good. Very good. I will give you that solution too. So what I've asked for is who got it done? Who's making it work? Okay? How about the guys over there? Who's confused? Who's confused into what I want? You're confused? So I'll say it again, all right? I want you to take 1 console write line, and I want you to write 3 string literals separated by a plus, each separated by a plus, okay? And then you can add in the escape sequence, \n, to do this in 1 line, okay? So here's how it should look. I want to take this string literal, and I want to put it here for now. This is what I would probably do. I want to take this string literal, and I'm going to put it here, right? And I can get rid of all these, because I don't need that stuff. And I can separate these by pluses, okay? I can separate these by pluses. Here we go. Look at that. Okay, I'll make it smaller so you can see the whole line. Like this. Take a look. There's the whole line. But this isn't right, because what this is going to do is it's going to smash them all together. There's no separation, right? So if I did this is part of the way true. If I did this, let's try it. Then you can see that it's going to do everything at once, like it's showing you. Everything is connected together, right? That's not right. What I want is separation, and I want new lines. I could add spaces if I want to here like this to separate them. I could do that, right? My name is Tom should be like a period too, right? So I could use spaces here to do that, like this, and that would be a little better. So it would be like this, some separation, like a little sentence, right? But that's not what I want. I want escape sequences here, \n, right? \n, right? \n, right? Actually, I don't even need the last one because it's going to give me an extra space. Let's try this out and see what happens. And if I did that, then I get this. I've taken literals, 3 string literals, added them together. The adding together part is called concatenation. That's just the word, okay? Concatenation. We're concatenating things together. We're adding them together. We're not adding them like you do in math. We're not adding 1 plus 1. That's a different operation. But this thing that we just did is called an expression. Here's some other expressions. Let's try this expression. I want to do a new console write line. Okay, here's the first console write line. I want to do a new console write line. And I want to do 1 plus 2. Okay, let's try that. Can we do that? Let's see what that looks like. 1 plus 2, right? And when I do 1 plus 2 and run it, okay, let's run it, 1 plus 2, I get 3. What? How come I get 1 plus 2 and I get 3? Why does it calculate everything? Well, what this is doing in here, it's called order of operations. So what this is trying to do is evaluate this expression first thing it does, and then after it evaluates the expression, it wants to pass this in as a numeric literal into the write line method. Okay, so expressions can be evaluated, and that's what's actually happening here. It's evaluating this entire expression, right? Adding it together, concatenating the string literal to make a big string literal, a bigger one. You can't see it, it's happening in the background. It's evaluating it, and then taking that whole thing after it's been evaluated and passing it into the method, all right? Which is what's happening here. Try something more complex. Try a larger mathematical calculation here, right? Like for example, 1 plus 2 divided by 3 times 15.6, to the power of 3, all right? Oh, it doesn't like the power. Let's just try it again. Times 15.6 times 15.6. How about that? Let's see if it does that and what it does for us. Okay, so I just did some random stuff, and if I press play, it's going to evaluate that expression instantly and come up with 1. Why did it come up with 1? How come? What the hell? Why didn't it give me a bigger thing? How come it didn't evaluate properly? There's a reason. Because I started off with 1, right? And then I'm trying to do this. If I wanted to do an expression, let's try this. Let's try putting in some parts, like 1.0f, which is a floating point number, plus 2.03f divided by 3.5f. And then we can put f's here too, like this, and see what happens when we do this. Will it evaluate this massive, a little bit longer of an expression now that everything is in the same type? They're all floating points. Let's see if that works. And if I was to do that, we're going to get 2202.9214. Why? It's not converting from integer to float. It's trying to convert the first time, and it's like, I don't understand what you want to do there. But now that I've told it that everything is a decimal number, it knows what to do. Okay? It knows what to do. So that's what this is. You can evaluate an expression. It converts it into a numeric literal and passes it into write line. Yes?
Is there a quicker way to do that other than putting f after every single number?
Yeah, you can leave the f out. If you leave the f out, now it's a decimal number. If you did this, right, and if I press play, then you're going to get this. F means I want to use a floating point decimal, which is just a smaller memory footprint than a double. This is a double. This makes it double precision, way higher precision. But I may not need that much precision because I've only got 1 or 2 character, 2 decimal precision. So I can reduce it to a smaller number, which means smaller memory footprint, right? Which means not as bad in terms of memory usage. So yeah, so we can evaluate expressions this way, which is kind of cool. So expressions are cool because we can concatenate different things, right? So what I want you guys to do, let's go back to what we had before. Again, you can always go back by undoing. So Control Z, 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 Z will put you back to where you were before, right? And what I want to do is I want to push this version up to GitHub. Let's do that. So I want to go back to this, right? Okay. And I want to push this version up to GitHub. I've added 3 lines. This is the one I want to push to GitHub. How do I do this? First, I save it. Okay. I can also run it again. That's also saving it right away. So I've put everything on separate lines. Here is the default that I use. This is right from the PDF, if you have a question. And I want to put this up on GitHub. How do I do that? Well, let's go back to my Solution Explorer, I'm going to pin this back on. I can unpin it if I want. Take a look. I can pin it, right? And I can unpin it, okay? So I can add it in here and hold it in here, or I can take it away, okay? And sometimes I want to pin it because it's easier for it to be on. I want to go back to my Git changes, and in this little box right here, I made a change. I added 3 lines here. I can make that commit message happen right here. Okay, careful. When you make a commit message, I want the commit message to be clean. They're not going to have swear words, symbols, or anything else that's useless. If it's a useless commit message, you will get 0 for your assignment. Yes?
What if you made a commit message within the code itself?
Commit message isn't in the code itself. It's here. That's a comment that you're talking about. Yeah. I'm talking about a commit message that's going to go to GitHub. So this message here is going to be on GitHub. It's going to be shared by your team a lot of times. Keep it clean, keep it professional, keep it relevant, okay? And so what I would do is, something like what I did. Added, 3 lines, 3 console write lines. Okay, that's what I did. And that's what you put in. It doesn't mean anything right now. It's really contrived, this message. I didn't really do anything with it, right? But now that I've added 3 console write lines, and if I click commit all, right, here's commit all, then I've committed. Question, is it on GitHub? What are the 3 things that I got to do? Add, commit, and push. Add, commit, and push. That's your protocol that you're going to need. Right now, I've done a commit. I've done an add because I've changed stuff, right? But I haven't done a push. To push with using this tool, press this little up arrow. You must press the up arrow. If you press the up arrow, it will initialize a push or initiate a push. And when I check up on GitHub, if I go back to GitHub, right? And if I check up on it, you can see now that I have 3 commits. Here are my commits. I have add Git attributes, I have add project files, and I added 3 console write lines. By the way, you know what the beautiful thing is? I can look at my project at the point where I didn't have these lines. Okay, let me show you that. So first, if I go back to code, and I go back to in-class exercise 1, and I look inside of program.cs, you can see that I have all the same stuff on GitHub that I have locally on my machine. That's what you see. And that's why I need it from you. So I can evaluate, did you do the right thing for today's lesson? Okay, that's why I use GitHub. I use it so I can give you a mark, so I can look at your code, right? And I know it's from you. That's the other reason why I do it, okay? And but what if I want to look at this? I want to look at a previous commit. I want to look at a previous point in time when I took a snapshot when I only had 1 line of code. How do I do that? Well, if I go back to code here, this little code, and I go back to my commits, and on the right, if you hover over, as an example, you can say view commit details. That's one thing you can do, but you can also go here and it says browse repository at this point. So if I browse the repository at this point, I can actually look into the past. And if I go back into my ICE1 and into my program, I can see that I only have 1 line of code. This is the beautiful thing about Git and GitHub. It allows me to look at all of your development history, what you added, what you removed, all that kind of stuff. It even does a diff, which allows me to look at the difference, things that you've added, from one to the next. So if I go back to code, right, and if I go back to my commits, right, there's other options here as well. For example, if I look at the commit details, click on this, it's going to give me the stuff that I've added and the stuff that I've removed. Additions are in green. Removals or deletions are in red. So I can actually see what you've done in your code, okay? And again, this is why Git and GitHub, this workflow that I'm getting you to do this semester and for the remainder of the time you're at Georgian, is super important. So we understand what's been done. You can see what the developer did, how they messed up, how they fixed stuff. You can see all that stuff. The whole history is right here, okay? And that's why I need it from you.
Mine isn't the commit is work.
You didn't push?
Don't I have to commit before push?
You commit here, and then you push, right?
Or the commit all?
Yes, commit all, yeah. And then you push. Did you push?
It's gray out the commit.
So is mine.
the commit is grayed out because nothing was changed. So here's something you can try. All right, let's make some comments like someone asked. What's your name again, sir? Lee. Lee said to me that, hey, what about comments inside my code? Like, for example, comments are 2 forward slashes are an inline comment. And I want to say something like adding 3 lines of code, okay? Now, if I save it, and if I run it, notice here how it's not grayed out anymore. Because I've made a change, I can push now. I can make a commit and push. If there's nothing that's changed, this will be grayed out. Nothing changed, right? So sometimes it's the order that you've done it in. Maybe you already pushed, when you had 3 lines, right? And that's why it didn't work the way it worked, okay? On this is an inline comment. We're going to talk about that next week. Let's do a header, a comment header. And I want you to do this for your application right now. So come at the top before namespace, and I want you to add in a comment like looks like this. So forward slash this time, and then I want you to use the asterisk, and then enter, and then close it off with a closing asterisk like this. Okay, so go at the top of your code and just type in /asterisk. Go all the way to the top of your code, all the way to the top, beyond namespace. Add some spaces in there. There we go. I can see you doing it. And then add in a /* and a star / at the end. This is a multi-line comment like this. You can add in some information. Here's something you can do, right? Name, right? You can add this in. And I want you to do this for your code, please. Right? And then maybe the date. You can add that in there too, which is today is September 5th. And maybe the in-class exercise 1. How about that? You can also add a short description if you want to. You can do all kinds of stuff here where we're testing stuff out. This is a multi-line comment, and the compiler ignores comments. It doesn't even look at it. You can put whatever comments you want anywhere you want, okay? Sometimes we can use it to comment out whole sections. Like, for example, what if I want to comment out this code like this? I can kind of put a comment here, and then I can go back down here and put a comment here. And this whole section of code has been commented out.
Why is comments useful?
Why are comments useful? Documentation. Documentation is super important for you to communicate with your other people that you're working with and yourself. Here's the thing. 5 years from now, do you really know why you wrote this program? Right? And you might say, 5 years, Tom, come on. 5 years from now, when you come back to this program and look at it, you're going to be like, what the hell was I doing here? You don't know, right? And sometimes when you're looking at old code that you've uploaded to a client or something that you've done for them, whether it's for a person you're working for, whether a game you're making, whatever, you just got to look at it for a second and go, what the hell did I do? What was I thinking back there 5 years ago? By the way, 5 years from now, if you continue with what you're doing, you're going to be a fantastic coder compared to now. So now you can look at yourself and like, well, look at that. I did that. That's shit, right? You're going to say that. And so the thing is, comments are really important where you can actually say something like, this code is really useless. It really is. It's not really something. It's just example, right? Or you can actually say better than this would be something like this code is an example of multiple statements. That's what that is, right? And that's a multi-line comment. You can do that. Danger, Will Robinson. Danger, right? When you comment out something like this, it stops functionality. So example now, you get nothing, right? It doesn't do anything. The compiler ignores comments, right? It also ignores anything that you've included inside the comments. It ignores them, right? So multi-line comments, and you can also do single-line comments. Let's just uncomment that. Okay, so undo, undo, undo. There we go. Okay, single-line comment. Right? Single-line comment. Now it'll do the two, but not the other one. Right, yes?
When we do the multi-line comment at the top, every time you press enter, it automatically puts it in asterisk.
It does.
But when you commented out the 3 lines, there weren't asterisks.
because it knows your Visual Studio editor knows you're doing a multi-line comment that's around code. You're commenting out something. Here, you're making a comment like, documenting something. Comments are super important because, and there's different types of styles of comments we're going to talk about in the future, but for now, I want you to include something like this in your in-class exercise 1. Let's put this up on GitHub. So I've added a comment. We're going to say added comment header is what we did. I'm going to commit all, and then I'm going to push to GitHub. Yes.
Mine is still grayed out even if I'm tracking
I'm experiencing that as to
It's still great.
I don't know why. Shouldn't do that. Push. See if you can push. We'll see what happens. For that button right there. Push it. Yeah. Yeah. No, it's because you've. It's your order, the order that you did it. And then, see, this is the problem. So, this is why I don't like built-in tools like this. You don't know what's really happening, right? In the background, it's doing all the commands by hand. Git add dot, git commit -m, initial commit, or whatever commit, right? Git push -u, origin main. Does all those things in the background. For us, for today, because IT sucks. I didn't say that, but IT is bad, right, for me. We have to do this, but next week, we're going to do everything by hand. And then you'll know, you'll have complete control. That's why I like command line git, because you have complete control, not this. You don't know what's happening in the background here, okay? All right, so this is for what we did together, okay? And if we go back to the PowerPoint, we did all this. And I talked about expressions, which is what we just talked about. And what I want to do is I want to skip down to variables for a second. Okay, we're getting there. We're almost at the end. Bear with me. Variables, containers for data. We're going to talk more about variables next week, right? But really what happens is we can save data inside of a variable, right? You learned this stuff in algebra, if you ever took algebra back in the day, in math. ax squared plus bx plus c, right? Where b represents one type of number and x represents the x-axis and so on. And you can say that y is equal to ax squared plus bx plus c, where y is the y-axis. So you have a relationship between the x and the y-axis with this formula, right? Talking math. It's the same thing here with variables here. You make a friendly name, and I want you to use variables with a name that makes sense, okay? Please don't truncate the variable name. And by the way, hint, hint, ChatGPT makes terrible variable names that I can instantly see, all right? That I know what they are. Please don't use, you'll be in trouble anyway, but that's why I'm saying don't do it, right? So there's two parts to making a variable. One is the declaration, and two is the initialization or assignment of that variable. I know we're running almost to the end. Bear with me. So here's an example. String is the variable type, we can say, right? Name, this name right here, is the variable identifier. It's just called name, right? And then this is the assignment operator, right? The assignment operator takes the literal rich and stores it inside the variable name. And so name now has allocated memory for this string literal, okay? Now, you're lucky because you're using C#. You don't have to worry about memory management. C# takes care of all the memory for you. C++, like we said earlier, you memory manage yourself, right? Everything is manual in C++. And in C as well, okay? So again, C#, Java, at the same level, they do automatic garbage collection. Same thing with all higher level languages. Automatic garbage collection, automatic memory management when you do stuff, right? So we've done this already. We know this, but now we're using a variable name instead of a literal. Let's try this, all right? So I want to make a string. So this is where I want to change this now, right? So let's try this out. So the variable is of type string. We're going to call this name, right? And then what we're going to say is we're going to say name is equal to, please put your name, right? And then we're going to do a console write line, console.write line. If I just do name, console write line, it's going to say Tom, right? Why? I want you to tell me technically why. Why is it going to tell me Tom? What is it really doing? I talked about this with expressions earlier. Yes?
It's taking the value from the name variable
And? Keep going.
printing it out as a string.
Almost there. You're almost at it right. Yes, you're almost there. Why? I'm taking the value of the name variable and doing what? Evaluating it. I'm taking it and converting it into a literal. That's what I'm doing. I'm evaluating the thing that I'm passing in. Name has a value of, quotations, Tom, a string, right? I'm taking it, evaluating it, and passing it into the right line statement, right? So if I press play now, right, then you're going to see Tom. Does that make sense? Variables hold data. Notice that the string variable is blue, so is the static void class internal namespace. All of these things are blue, and they're blue because these are magic keywords, let's call them keywords, that belong to the C# language, okay? Keywords are special words that you cannot use in your own identifiers. You cannot use these as variable names. I can't use string as a variable name because it's taken. It's a keyword. It's reserved, okay? Some people call them reserved words. Some people call them keywords. That's what they are. So string is the data type. If you hover over, it tells you, it represents text as a sequence of UTF-16 code units. Okay? And name, then, is of type string. We can say that name, that's how you read it. Name is of type string. Okay? Now, if you look here, it doesn't really show you that, right? If I go back to my Solution Explorer, if I open it up, you can see that all I have is this. It doesn't show me this detail right here, okay? One other thing, notice my Solution Explorer has a check mark, a red check mark next to it. Notice that? There's like a red check, tiny red check mark there. Because I've made changes, right? This shows me that I have a change that I haven't pushed to GitHub. That's what this means. Okay, next. Now that I've done this console write line, I could say says hello, or I could add this. So I could say says hello. Okay, I could do that. Name says hello. What's happening here? I'm taking name, I'm injecting it inside of this place. It's evaluating it, converting it into a string literal, concatenating it with says hello, and then outputting it to the console. That's what's happening. I'm evaluating it here inside of this place right here. Now this was to be your you do, right? But we're doing it together because of IT's thing this morning, right? It's not that difficult, but it was to be a little bit of a challenge for you guys. Not really a big challenge at all, but this is it right here. Let's push this to GitHub. So again, I want to go to Git changes. I want to make sure it runs first. Let's run it first. Here it is. Tom says hello. And then what I want to do is say something like, something like added string that holds, value of user's name and output to the console. Now this is a very long commit, okay? Take a look how it's almost like 2 lines.
It's still grayed out.
I'm going to come back to you in a second. I told you it's a bad thing, this Visual Studio that's on your machine in front of you right now, okay? You may have to do this again on your personal machine later on, okay? But if you notice, if I do that, and if I press commit all, right, and if I push it to GitHub, like right here, if I click that push button, and then when it initializes and pushes everything to GitHub, and if I check it on GitHub, let's check this out now, you can see that I have now 5 commits. Here's my 5 commits, and these are them. Add git attributes file, added project files, added 3 console write lines, added a comment header, added string that holds value of user's name and output to the console. That's pretty long. And let me see what does it look like when I do that. Look, it kind of truncates it, right? See how it's truncated here? It's truncated, I mean it's cut off. It's cut off here because it's too long. So, warning, long commit messages are going to be like this. And you don't want that. You want them to be succinct. You want to find out ways of communicating to your team that's much smaller than this. So that I added, string, name. It's probably pretty good, right? And the output is because you're testing it, right? So I added a string and I assigned a name to it. One more thing, last commit, and we'll stop for the day, I promise. This is okay. This is okay, but we can make it better. How do I make this better? Yes?
You can make the call like declaring the variable and setting the variable value into that.
I can do declaration and assignment. I'm going to use all the words today, okay? I can do declaration and assignment in the same line at once, like this. So I can take this little assignment operator, back it up, and then I can kind of make it appear here and do this. This is also the same thing. However, I want to say that this is not the same exact thing that I'm doing, okay? I'm declaring a variable here. This part is declaring the variable. Declaring the variable sets two things, the name and the data type. That's what I'm doing. That's what declaration is all about. Name and data type. What type of data am I going to store here? String, okay? The next part, the assignment part, is this part. This is a separate operation, okay? This part uses the assignment operator and takes the value of the string literal and literally dumps it into my name. That's what it does. So I take the string literal and I save it into my name, okay? And I'm doing that all at once. This is okay, but I want to mention that sometimes this is not okay. And the reason for this is because sometimes you want to separate declaration and initialization, right? We're initializing this variable. What if I did this? What if I took this away and just did this? What is it gonna, it's gonna give me an error. Take a look. If I don't initialize it with data, because I'm declaring a variable, I get an error that says name is null here. It's null. Null is mean like there's nothing in it. You're trying to allocate memory for something that doesn't exist. That's what this means, right? It's an error. You have to initialize. And that's why we need to do something like this, or two lines where you declare and then initialize in the separate line. This is okay. Let's add this up to GitHub. Let's try this out first, and let's put this up on GitHub. There it is. We're good. You can see it's the same thing. And then in my message, I'm going to say, joint string declaration and initialization. Commit all and push. Question for you. Last question for the day. Do you have to push every single time to GitHub?
Yeah.
Don't have to. However, it's not bad practice. When do you commit? Sorry, I asked another question. When do you commit?
When you're done for the day.
When you're?
Done for the day.
When you do anything, you make any changes. When you add, remove, fix a bug, go to the washroom, whatever you're going to do, commit, my friends. Commit. Commit often. But you only need to push once if you don't want to, right?
So I can commit multiple times?
You can commit multiple times because it's committing locally to your local repository. All those commits are local. And then you push them across the remote and they're on GitHub. Guys, thank you so much. The in-class exercise 1 that we've done today is due on Monday at midnight. Monday at midnight. Please record your video. Remember that you have to do that, okay? And when you record your video, I want you to discuss what you've learned today, right? That's part of the discussion. Talk a minute about what you understand, okay? That's all I want you. Don't read the code, just talk about what you understand, okay?
Do I have to use the exact terminology?
I want you to try and use the exact terminology and understand what I'm trying to say, all right? Because when you use the terminology, you get better at understanding what we're talking about. Then we're using the same language, okay? Make sense? And it's also better for you in an interview. Guys, thank you so much. Remember, 2 things, YouTube video and GitHub link. And if you haven't included me as a collaborator, please do so.
What's your username? What's your username on there?
For GitHub, it's my last name at hotmail.com. Okay, thanks guys.
Find the